Okay, so this is a water molecule. This is how looks like, 2H and 2 hydrogen and 1 oxygen. Sometimes what happens, these hydrogens come off. So you can see these hydrogens came off here. Those are known as hydrogen ions. And that leaves behind this OH. That's hydroxide ions. So water molecules separate into hydrogen ions and hydroxide ions sometimes. If there is a higher concentration of these hydrogen ions in water, that's going to make it more acidic. So that's going to be maybe lemon juice. So a measure of concentration of hydrogen ions is pH. So it's a measure of the concentration of hydrogen ions. More hydrogen ions you have, the lower the pH is going to be, and those are these things. So so lemon juice or other stuff that you find at home, vinegar. So those are acids. If it has lower concentration of hydrogen ions, it's bases. So I'm going to show you the scale for acids and bases. It's going from 0 to 14. There will be one question on pH on the quiz. If it's 0 to 7, it's acidic. 7 is neutral. 7 to 14 is basic. So maybe I'll give you an example. This is a pH. Is this acidic or basic? And you're going to have to tell me. Acid is the substance that releases hydrogen ions. And then pH is going to be lower than 7. So this is where it's going to fall. Lemonade, vinegar, battery acid. Bases, substance that releases hydroxide ions. And that's going to fall in this area. Ammonia or the drain cleaner that comes in this area. These are some of the items you might see at home. So battery acid, pH of 0, really acidic. Gastric fluid. Gastric is referring to your stomach. You have HCl acid there. So when you eat food, if there's any bacteria, this acid kills the bacteria. And 7, neutral, is pure water. So pure water is 7. And then all the house cleaners, oven cleaner, bleach, drain cleaner, it's basic. So 13, 14, that's basic pH there. Now, another term I'm going to give you is buffer. And this word buffer came around before the internet. If you're trying to play a video on the internet, it starts buffering. And what it's trying to do, it's buffering so it doesn't, stop in the middle or go forward or something like that. So that's where that term came from. But in chemistry, this, term came around a long, long time ago. So what buffers do, they're going to keep the pH of a solution stable. So if you have a buffer added, then the pH is not going to change much. So what this graph is showing, you have a buffer here and you're adding acid to it. And when you're adding, it's not really changing unless maybe you add a lot more, then it's gonna drop. Whereas here's pure water, there's no buffer in it. And every time you add acid, the pH drops, it's going down. But if you have a buffer, it's gonna stay stable unless you maybe make a big change in the amount you're adding. So buffers are going to keep the pH of a solution stable by donating or accepting ions. I'm not going to go in detail how you get these numbers. If you're taking chemistry, they can do that. I just want you to understand the pH scale. And then talking about pH of your blood gases. So we talked about homeostasis. We said your blood sugar level has to stay in that range. And then what else? I think that's what your temperature have to stay in that range. There's a range that has to stay in. Same thing with the blood pH. Blood gases pH has to stay around 7.4. That's normal. If you start hyperventilating, you start breathing really, really fast, it's gonna drop. That's acidosis. And you can notice if it goes from 7.4 to 6.6, that's not that big of a difference. It can cause death. Same thing here, if somebody puts some poison in your food and it can cause alkalosis and then death. So it just has to go from 7.4 to 7.8 to cause death. So this is really, really important. And you have buffers in your body like carbonic acid, and they're going to keep the cells and tissues within a consistent range of pH, so at the homeostasis.